Hello, my lovelies! It's Susanna, and today I want to show you how to solve this problem. It was a question in an admission test for the University of Oxford, so let's see if we can solve it. An irregular hexagon with all sides of equal length is placed inside a square of side length 1 as shown below. We get a picture to our problem, which is not to scale. And the question is, what is the length of one of the hexagon sides? We get 5 different answers to our question, and we have to pick the right one. So let's take a look at our square here. We get the information that the side length is 1, so we had side length 1 of our square, and inside our square we have our hexagon. So the first problem is to find this hexagon, but it is in here, so we have 1 side, 2, 3, 4, 5, 6 sides. This is the hexagon we have to work with now. We get the information that all sides are of equal length, and we have to find the length of one of these sides. So I call the length of one of the hexagon sides x, and then we have x here as well, because all sides of our hexagon are of equal length. It is an irregular hexagon, so not all angles have to be the same size, which is okay. It's not the case here, but they told us that it is an irregular one. Okay, a nice version of this picture is here now, and now we just have to find the length of x. Where to start? We could start here in this triangle that we have here now, because it is also a right triangle and one of the sides is of length x, what we want to find. So maybe we could use the Pythagorean theorem to find the length of x. We only need the length of this side here and the length of this side here. How long are they? Well, we get the information that this side of the square is of length 1, and this part here is of length x. So this remaining part is the whole side minus this part here. So it's 1 minus x. The same here, from the whole side, from the 1, we subtract the x, so that's the length of this part that we want to work with, so it's 1 minus x as well. And now we're ready for the Pythagorean theorem. For this, we first have to find the hypotenuse of our triangle. That's the side that lies across the right angle. So this side here, that's our hypotenuse. And the Pythagorean theorem says then, take one of the other sides, so we start with this one, it's 1 minus x, and square this, so we write it in parentheses and square it, and then add the length of the other side, which is 1 minus x as well, and square this as well, so we write it in parentheses and square it, and this equals the hypotenuse squared, so x squared in our case here. We have an equation now. X is our only variable in here. We can solve this equation for x. And then we found our solution already, because that was what we were searching for. So let's see how we can solve this equation for x. Maybe we start on the left side by expanding the bracket. So we have a squared bracket here. That means we can take the bracket and multiply it by itself. And then we have the plus. And the same here. We have squared bracket, so we take the bracket and multiply it by itself. On the other side, we have our x squared. Now here the multiplication. We FOIL it out. So we multiply every element from the first bracket with every element from the second bracket. We start 1 times 1 equals 1. 1 times minus x equals minus x. Minus x times 1 equals minus x. And minus x times minus x. Then we have plus x squared. Then we have the plus here, and this multiplication is exactly the same as this one, so we can just take our result and write it here again, and on the other side we have our x squared. Now let's simplify. We start with the x squared terms. So we have x squared plus x squared, which equals 2x squared. Then we have the x ones, minus x, minus x, minus x, minus x equals minus 4x. And then the numbers 1 plus 1 equals 2. And on the other side, we still have our x squared. We bring the x squared to the left side by subtracting x squared on both sides, and then we get 2x squared minus x squared equals x squared. Then we still have the minus 4x, the plus 2, and on the other side this cancels out and we get 0. This is a perfect quadratic equation that we can solve with the quadratic formula. So I write the formula down first. We find our solutions to this equation by doing the following. Minus b plus minus the square root of b squared minus 4ac divided by 2a. What is my a, what is my b, and what is my c here? A is always the number in front of my x squared. If you don't see any number, it is a 1, so a equals 1. B is the number in front of my x with a sign, so it's negative 4. And C is the number that doesn't have any x here, so it's the 2. And then we put everything into our formula. What do we get? Minus. B equals negative 4 plus minus the square root of b squared. So we take our negative 4, put it in parentheses, and square it, minus 4 times 1 times c equals 2. And in the denominator, we have 2 times a, so 2 times 1. Let's calculate this. Minus 4 equals 4. Then what do we have in our square root? Negative 4 squared equals 16 minus 4 times 2 equals 8. So 16 minus 8 equals 8 in the square root. And in the denominator, we have 2 only. This is our result. We get 2 results because one of them, so our first result, I call it x1, is if we take 4 plus the square root of 8 and divide it by 2. And our second solution, I call it x2, is if we take the minus, so 4 minus the square root of 8 and we divide it by 2. We found 2 solutions. Let's go back to the beginning. Here are our solutions. We got 5 different solutions, and none of these look like our solutions yet. Perfect. Okay, let's see. We got 2 solutions, which is a problem in itself because we only can pick one. So let's see if both of these are valid. What about the first one? We have 4 plus the square root of 8 divided by 2. This is the value for our x. X is part of the square here, so the side of the square was of length 1. So x has to be smaller than 1, otherwise it wouldn't fit into the square, right? Okay, is this smaller than 1? We have 4 plus the square root of 8. The square root of 8 is something positive. So to the 4, we add something positive, and then we divide this by 2. This is larger than 1. Even if the square root wasn't here, 4 divided by 2 equals 2 already. So this is not a valid solution. It's too big. Okay, so what about our second solution? Well, let's simplify it and see if we get one of these answers here. We have one big fraction and we have this minus here in the numerator, so we can write this one big fraction into 2 smaller fractions that are connected with this minus here. The denominator stays the same and the first numerator is the first part and the second numerator is the second part, the square root of 8. Okay, let's calculate. 4 divided by 2 equals 2. And here we have to do something with the square root of 8 because in our solutions here, there is no square root of 8. So we can write the 8 as 2 times 4, right? And because we have a multiplication in our square root, we can write this as 2 separate square roots. So the square root of 2 first, and then multiplied by the square root of 4. And the square root of 4, we can calculate this. This is just 2. So we can cancel the 2 and the 2 here. So our result is 2 minus the square root of 2. And this is answer B. I hope you enjoyed it, and I'm curious how you solved this problem. So please let me know in the comments. I wish you a wonderful day, and I hope to see you in one of my next videos. Take care.